In this course, now we have been exploring the relationship between two very large fields of computation, artificial intelligence. These two fields are information retrieval and natural language processing. We remarked that these two fields have a very natural connection between them, because both the fields deal with text primarily and are concerned with how the language phenomena are manifested in the form of sentences, paragraphs, documents, and so on. In information retrieval, the key point is the way the information need of the user is met. The user poses a query to the search engine, and the documents which are retrieved are ranked according to the relevance of the documents with respect to the user's query. Natural language processing, on the other hand, is concerned with the meaning content of the documents, sentences, paragraphs, and so on. And clearly, the meaning of a document has lot of bearing on the relevance of the document with respect to a query. We might remark here that there is a field of natural language processing called summarization, where the document's contents are summarized and presented to the reader. Now, the summary can be formed in two different ways. One is query specific summary, and the other is query independent summary. So, a user can have a question in mind, and the summary is presented to the user with respect to this particular question. The other kind of summary would be a general gist of the document independent of any query or question. All right. So, we understand that the information need is expressed in terms of query, and the search retrieves information to satisfy that information need. So, we proceed with the lecture today, and today's topic is describing cross-lingual information access, which is a very large project in India, and then move on to information retrieval basics. So, we started describing the cross-lingual information access project of the country, which is a flagship project of the government, and the reason is that the users have information need which is best expressed in the language of the user, the native tongue of the user. The comfort level with English in this country is about 5% of the population, but the information need is a very real need, and it so happens that the information is expressed mostly in English, and therefore, we have to do something about crossing this language barrier. All right. So, we proceed with the slides, and I remind you that in artificial intelligence, information retrieval's entry into the field is a recent phenomenon because of the enormous presence and impact and importance of the web. And in the core areas of artificial intelligence, namely search, reasoning, learning, planning, and so on, they do contribute to all these areas on the outer circle, and information retrieval also makes use of AI techniques. We remarked that the most important quantity in this discussion is user satisfaction with respect to his or her information need, and this satisfaction depends on the way the documents which are retrieved are ranked according to their relevance. This ranking, on the other hand, is a function of the coverage of documents, how much of information from the web we have been able to capture and keep in our repository to satisfy the information need. The other point is that the user's query needs to be processed correctly. We have to identify the root words, the stems, the named entities or proper nouns, multi-words or compound words, and so on. And if we do all this properly, then we get a set of documents which are relevant, and the most relevant document does appear on the higher side of this list. So, and then user satisfaction is achieved. Now, in this context, we started discussing India-wide cross-lingual information access endeavor, and this is motivated by crossing the language barrier between Indian languages and English, and also amongst Indian languages, so as to satisfy the information need of a user who knows, let us say, only one language, namely his or her mother tongue, or at best one more language. So, English is still the most dominant language on the web. That is the motivation for keeping English always in target. This contributes 70% of the content on the web. The number of non-English users is steadily rising all over the world. That is also a fact, as this view graph or the bar graph shows. We find that the top 10 internet languages, as reported in November 2007, that is about 3 years back, is English, where 380 million users are English speakers, 380 million users of the web are English speakers, followed by Chinese at 185, Spanish at 113, Japanese 88, French 64, German 62, Portuguese 51, Arabic 46, Korean 34, and Italian 33. And rest of the languages comprise about 206 million users. But this profile is changing quite rapidly. The number of non-English users is steadily rising all over the world. English penetration in India is estimated to be around 3 to 4%, mostly the urban educated class, and we need to enable access to above information through local languages. So, there is a very real need which needs to be addressed. And we showed this picture last time, where the query here is shown to be Tirupati Yatra, that is visit to Tirupati, and this is the query in the mind of the user. However, this is only an expression, partial expression of the real information need of the user, who might want to know many things about Tirupati, about how to reach Tirupati, where to stay in Tirupati, what are the hospitals in Tirupati, where the police station is, how to go from Tirupati to the shrine of the Lord Venkatesh, and which is at Tirumala. So, all these information needs to be fetched and shown to the user. So, this query is given to the CLIA engine, the search engine, which is then processed and converted into English by using language resources, and this query is now taken to the crawled and indexed web pages. The index table matches the query words, the keywords in the query, with words present in the index table, and then the documents are fetched which are on Tirupati, and they are in English though, and therefore, these have to be now shown in Hindi, because Hindi was the language of the query. So, not the whole document need to be translated, but only the important part of the document, which is an indication of what it contains with respect to the query, that is translated and then shown to the user. So, this is the process: query processing, crawled web pages referral, fetching of documents, and output shown to the user. So, the challenges which are involved in cross-lingual information access, and we will understand these better when we do information retrieval basics. Indexing, retrieval, and ranking of multilingual documents is the main concern of the problem. Indexing, retrieval, and ranking of multilingual documents. Web data is not clean and regular. Different font encodings exist, some of them are proprietary. Spelling variations is very common, different document encoding. So, encoding is indeed a very important concern, almost a headache for people working with text. And the reason is that the documents are many times available in proprietary font. For example, the newspapers have their own font typically. In Hindi, Navabharat Times has its own font, and another Hindi newspaper also has its own font, and therefore, if any search string is used which is not in the same font, the encoded font of the newspaper, it will not be able to match the content and retrieve the information. So, this is a very important problem, and by the efforts of the Ministry of Information Technology and Communication, there has been some amount of consensus and uniformity with respect to the encoding of Indian language font. Now, more or less people are used to adopting the UTF-8 or Unicode font to be used for all Indian language documents. So, this is a very important point because of this non-uniformity and non-standard fonts. Search, translation, all these large activities do take a back seat unless we achieve this uniformity. So, this is the point which was mentioned on the slide as the second point. Web data is not clean and regular. Language identification is needed to invoke appropriate language analyzers. This is also a very important point. In Devanagari, for example, the languages which use Devanagari script are Hindi, Marathi, Konkani, Nepali and Sanskrit. So, all these languages use the same script, namely Devanagari. Now, the question that arises is that if I look at a document on the web and we see that the document is in Devanagari, how do I know which language this document is written in? Is it Hindi or is it Nepali or Marathi and so on? And Hindi content of course is very large on the web. Marathi follows Hindi, but Marathi document also is not very little, and therefore, when we retrieve documents with respect to a query, suppose the query is in Hindi, the search engine should not retrieve Marathi documents. So, language identification is very important, and if you are building language specific index table to facilitate a particular language based search, then it is important to do this language identification. Then we see that processing of the query involves a number of fundamental NLP research problems like query disambiguation, machine transliteration, whereby the proper noun is converted into the script of the target language, named entity recognition, multi-word recognition. Multi-word recognition is important because for a string like Good Friday, this whole compound word has a specific meaning which pertains to Christianity, and those documents have to be retrieved. Good Friday does not mean a Friday that is good, it has a specific meaning. So, these NLP tasks are involved. Now, the Crosslingual Information Access project in the country is a consortium project. Indian language CLIA engine is under development. There are 6 Indian languages which are in the purview of the project. Recently, 2 more languages have been added, namely Assamese and Gujarati. The output happens in Hindi, English and the input language of the query. So, that means the output can be seen either in the language of the query, which means monolingual information retrieval, or in Hindi or in English. The domain is tourism. It is proposed to add health and maybe agriculture, but the addition of domain is sometimes a challenge because new resources have to be developed, though the computational tools would work from one domain to another. And this large project involves 10 academic institutes all over the country, IITs, Indian Statistical Institute, CDAC, Anna University, Jadavpur University and so on. IIT Bombay is the overall coordinator, and it is also responsible for Hindi and Marathi language verticals. Now, the whole system includes full-fledged search features along with snippet translation, summary generation, information extraction. So, all these you understand is towards satisfying the information need of the user, even if the user does not understand English. The public portal which is used here is given here, http://www.clia.iitb.ac.in/CLIA beta ext, and within IIT we have to give the port address, namely 8080. So, this large block diagram which captures the functionality of different modules in the CLIA system can be understood better after we cover the information retrieval basics, but I draw your attention to some large top level activities. So, the language analysis achieves stemming, and the root words are obtained from the query. Named entity recognition achieves the proper noun detection. Multi-word expression identifies things like Good Friday. Query translation achieves conversion of words into target language words. Query transliteration achieves converting proper nouns in the query language into the proper noun written in the script of the target language. Query disambiguation produces the actual meaning of the words and thereby improves the precision of the documents which are retrieved. This query is then referred to the index table. The index table then produces the documents which match the keywords. So, searching is over. Now, the documents which have come are ranked in the order of their relevance. The document summarization happens, snippet generation happens, template based information extraction happens. All these are translated and shown to the user in his own language. All this of course, does not come free, they are supported by lots of offline processing. So, the web is crawled for documents, there are font transcoders, there are CMLifiers which embed rich tags in the document retrieved, which are used for output processing, information extraction and so on. Language identifier identifies the language of the document. Domain identifier ascertains that the page is indeed from tourism domain, which is our focus of work. Named entities are detected and these are stored with special flags in the index table. This improves the ranking of the documents. Multi-word expressions are also detected and stored with a flag marked this way in the index table. The information extraction database is referred to for information extraction. There is another line of work in the whole system, which is semantic search. There is a representation of sentences in the form of what is called universal networking language graphs. So, these search is also called semantic search. It is supposed to produce more high quality results, and the user interface also bears the burden of taking user query and presenting the information in a lucid, attractive way to the user. All right. So, this is the top level block diagram of the Crosslingual Information Access project, which is going on in the country under the leadership of IIT Bombay. So, these stars show various activities which are under different stages of development, crucial activities with different colors, not so crucial activities also are shown. Now, this project has got quite a lot of coverage in the newspaper. Leading dailies have covered our work in terms of what the impact of this project will be. All right. Now, we move on to information retrieval basics, and we have made use of two well known texts. One is Modern Information Retrieval by Ricardo Baeza-Yates and Ribeiro Neto, and the other book is a more recent one, which is Introduction to Information Retrieval by Manning, Raghavan and Schutz. So, these textbooks provide us with some of the basic material which are important to have a good grip on information retrieval. So, the reason for studying IR as a basic course at various academic institutes, research labs, etc., is that IR is now really at the center of the stage of activities. In the last 20 years, IR has been mainly concerned with classification and categorization of information systems and languages, user interfaces and visualization. but IR was limited in its scope, and people's interest on IR also was in specific problems, specific domains and so on. For example, in the library information system, retrieving information about books was considered an important part of information retrieval, and the book search could happen in terms of authors, the book title, and sometimes even on the topic in which the book is the topic of the book. So, in the library information system was an important consumer of information retrieval techniques. So, however, the area was still seen as an area of narrow interest. Advent of the web changed this perception once and for all. Web has become such a gigantic repository of information with the need for retrieving information in a sophisticated way, high quality access and fast access. These things have changed the field of information retrieval completely. So, web is looked upon as the universal repository of knowledge. It is almost like a fairy tale figures, the wise man, the universal wise man who knows everything. So, people go to the web first for any kind of information need. It is the universal repository of knowledge. The information is free or very low cost with universal access. There is no moderation, which is its strength, with a little bit of weakness, but that indeed is the strength. Everybody is contributing information unhindered, uninhibited to the web, and that is making it more and more powerful. There is no central editorial board, nobody is snooping on anybody, nobody is looking over the shoulder of anybody to say that yes, this information you should not put on the web, this information you should not look at. It is a completely free territory of information, which is a tremendous power as far as information access is concerned, and many problems do exist. Many problems do exist because information retrieval does not happen free of cost. There are many challenges, large challenges to be solved. However, this is a new world, a free world with information for all, and this is a tremendous achievement of computing, networks, artificial intelligence, language processing and so on. All right. So, we go to the slide and see that the user task and information retrieval can be modeled by means of these schematic. So, user poses a query to the retrieval system, the information base is referred to, what comes out is presented to the user can do browsing of the web. Retrieval is information or data which is retrieved, retrieval is purposeful. Browsing on the other hand may not be completely purposeful, it is simply glancing around whatever is there on the web. So, this situation can be likened to a tourist who visits a place with a particular purpose in mind. For example, I go to Jaipur with the specific purpose of seeing the city palace. So, this would be akin to purposeful retrieval. Another situation could be I go to Jaipur and simply roam around looking at interesting things and looking at also things which are ordinary, but still form part of the life and sights and sounds of the city. So, the difference between browsing and retrieval is this. The basic concepts can be also captured by means of this pipeline or a schematic, which gives the logical view of the document. So, the documents have their own structure, there are accents, spacing, etc., paragraphing, listing, chapters. These are the structure specific features of the document. So, when these tags, paragraphs, etc., are obliterated, then we have a large string which is corresponding to the full text of the document. There are stop words, that means words which are present in all documents, and therefore, they do not lend any special information with respect to the identity or the specific information content of the document. So, the stop words are those entities which are required to form the document, but are not distinctive features of the document. An example of these would be the articles like a and the. They are present in all documents, and therefore, they do not bring in any specific information about a specific document. When information retrieval happens, it is the nouns and noun groups which play the central role in information retrieval. Nouns are the most important carriers of information. Verbs, prepositions, adjectives, adverbs, etc. Serve either to qualify these nouns or to glue together the nouns to form a particular information content. The noun groups pass through what is called stemming. Stemming is very crucial because the form of a word in the query may not be same as the form of the word in the document that satisfies the information. For example, the word dog, the plural form is dogs and the singular form is dog. The query may contain the word dog in singular form, the document may contain it in plural form, and then if the system says that these two entities, namely the query and the document, do not match because there is this singular and plural difference, singular and plural disparity, then this is not the right situation. The document does indeed contain the information to satisfy the query. Just because the word is not in plural form and the matching fails, this is not a good idea to say that this document is not relevant. So, words typically transform themselves according to morphological information, according to features, and when that happens, it is important to bring them up to a common stem. Dogs and dog should become dog, and then the matching can take place. So, this is the importance of stemming. There are languages which have very complex morphological processes. The word gets transformed in a complicated way and in a very rich way into many different forms. So, if the query and the document do not match because of morphological variations, it is not a good idea. So, stemming is very crucial. Then we find that there is this manual indexing. Manual indexing takes the stems and essentially creates a very large array of words which point to the documents that contain them. This is also called inverted indexing. We are going to discuss all this in detail. Now, when the query processing happens, stemming happens, paragraph, tags, etc. are removed, then we can see that the structure and meaning of the document is lost in the representation. So, this is a very important point to note. The document comes with a structure meaning. When it has gone through this kind of destructuring, stop word removal, identification of nouns and their consequent stemming, whereby the suffixes are stripped, then what is happening? Then maybe we should say that the document has been stripped down to its essential elements, the elements which are required for presenting to a user a logical view of the document. That logical view simply says that these are the important keywords in the document, and whatever be the information need, if this information need contains those keywords, then this document would satisfy that information need. It is very likely to satisfy that information need, but the fact remains that the document's representation to the search engine is in terms of a set of keywords organized in a table, okay, and that is hardly close to whatever the information, whatever meaning the document contains. So, this is an important point to keep in mind. If you compare this with another field of natural language processing, namely machine translation, then it is crucial in machine translation to keep the meaning content intact. And in that meaning content, the stop words like articles, prepositions, conjunctions, they play a very crucial role. So, we sort of tend to see that things which are important in natural language processing and information retrieval have some commonality and some difference, very important difference. So, nouns are important in both places, information retrieval and NLP. Both places give a lot of importance to nouns, they are the carriers of information. Information retrieval does not care much about the stop words, articles and prepositions, conjunctions, etc. But in machine translation NLP tasks, these words play a very important role. They cannot be deleted, they cannot be ignored. So, this we see as an important difference between natural language processing and information retrieval. So, they coincide in terms of nouns, but they diverge in their importance given to the function words. Let us keep this point in mind. Content words important for both, function words important for NLP, crucial for NLP, but not so for information retrieval. Okay, so, proceeding with the material. The retrieval process happens in this way. The user interface takes in the query. There are so the query is an expression of the user information need. The text operations take place on the query. There is a logical view of the text operation, that means essentially keywords. The query operations happen, and it is possible at this stage to get the user feedback. We will see it later as to how it happens. Then the query operations launch a search. The search retrieves documents which are ranked and shown to the user. The user, based on the ranked documents, can give a feedback which can come to the query box again, and then again the search process would begin. So, this looping can happen until the user is satisfied with the retrieval. Okay. In practice, whether this happens or not, this is a separate question, we will discuss this later. And in the offline, at the background, something else is happening, which is that there is a database manager that has a massive text database at its disposal. Those pages, those documents are indexed, which again is a logical view of the information repository, the huge information repository, which needs to be referred to frequently. And then there is this inverted file, which means that there is an indexing created. It is called inverted because we have a mapping from words to documents rather than the other way. So, words to documents is the inverted index. Now, we come to a very deep and important point, namely the issue of information retrieval models, IR models. So, user task is retrieval, which can be in terms of ad hoc filtering, or the user task is to do browsing. So, when browsing happens, there is this flat file system, structure guided file system, or hypertext. So, one could browse either a flat file, which could be a .txt, .pdf, .doc, any of those files, or it could be semi structured data or a completely structured data. Hypertext is semi structured data with tags embedded in text, and completely structured data would be tables, for example. Under structured models, we have these non overlapping lists. There are these proximal nodes, where the database is in the form of entities and their relationships. It is a large graph of the content of the data. And then there is these classic models of information retrieval, namely Boolean, vector and probabilistic models. So, what are we saying here? What we are saying here is that the information retrieval model tries to capture relevance. Okay. The most important concern of information retrieval model is trying to capture this elusive concept of relevance. How does one capture relevance? That means, how do you know that for a particular query, whatever is contained in the document is relevant to that query? Okay, this is the question of relevance, very important point. So, the slide says that the classic models do relevance modeling which is same as IR modeling, either through Boolean operations or vector space operations or probabilistic modeling. We will discuss this one by one, and as we do so, we also bring in how NLP can or cannot play a role in this very crucial concern of information retrieval, namely relevance. Boolean vector and probabilistic models of IR or relevance refer to set theoretic modeling, fuzzy modeling, extended Boolean modeling, algebraic modeling, generalized vector, latent semantics indexing, neural networks. Probabilistic is inference networks, belief networks. Okay. So, under set theoretic we have fuzzy and extended Boolean modeling. Under algebraic we have generalized vector modeling, latent semantic index based modeling, neural networks based modeling. Under probabilistic we have inference network and belief network based modeling. So, I would like to once again point that these are different terms, and one should not lose sight by the force of terminology of the fact that their sole purpose is to capture relevance. Okay. How do we match the query and the document? What is the best way to match them? So, this matching can happen at various levels. It can happen at a very superficial level, where the surface entities on the query and the surface entities on the document are matched. On the other hand, the matching can be much deeper. The meaning of the query and the meaning of the document are matched, and then the relevance is deciphered. So, it is clear that if matching at a deep level is carried out, then we are likely to have a far more robust and far more accurate effective model of relevance. But this may not be practical at the scale of the web, where the user's patience with the search engine can be only so much. Okay. If I am not receiving an answer to my query, however imperfect, in about a second, then I lose patience with the search engine, however sophisticated its operations are. Okay. So, see the psychology of a search engine user. A search engine user can tolerate some imperfectness, it can tolerate some limitations, inaccuracies and so on, but the speed of the response has to be really fast. And then the user would think that I would apply my mind and look at the list of documents and get my information need satisfied. Okay. So, we proceed further and look at this very important slide, which captures the essence of information retrieval. We have here the query words Q1, Q2, Qn, the search box Qi are query terms. The documents here are represented as a ranked list with respect to the query, and how the document came, how it came was through this index table. This index table contains the terms which point to list of documents with respect to each term. For example, the word could be Taj Mahal, and all the documents which contain the word Taj Mahal are linked to this cell of the index table, okay, in a linked list fashion. Okay. So, if there are thousands of documents which contain the word Taj Mahal, then the Taj Mahal entry in the index table will contain a pointer to all these documents. The query words are taken, they are stripped to their stems, so that the stems present in the index can be matched. So, the query keywords are then matched against the index table. Wherever matching occurs, we pick up the document and bring it for relevance calculation and ranking. Okay. So, if high ranked relevant documents are present, if relevant documents are given high rank, so that they are in the top of the list, then users information need gets satisfied. So, this diagram would tell us what is the best way. Okay. We could actually match documents, bring them and then order them according to their relevance. Okay. So, this ranked list is the final product of searching, and that would require language analysis in a when we go to more sophisticated level. So, here is a diagram which also incorporates what is called relevance feedback. So, user has presented his query in the search box, Then database, algorithms, data structures, all of them come into picture. The index table and the documents are referred to. These are shown to the user, and relevance feedback can be given to the search engine once again, saying that I found the 5th and 11th document to be very relevant. So, consider using the terms present in these documents added to the query, and the search is relaunched. This time the retrieval performance is better. Okay. So, this is a closed loop situation. Now, we come to a very important point, which is how to check the quality of retrieval. This is done in terms of precision recall and what is called the F score. We will explain all this carefully. So, we make some remarks with respect to the measurement of quality of retrieval, quality of the search engine. So, the point is that what is returned from the search engine is a list of documents. Okay. How good is this list of documents? Do we have a lot of relevant documents in this list, and are the relevant documents appropriately placed, so that an irrelevant document is towards the end of the list, relevant document is towards the beginning of the list. All these are questions with respect to the quality of the retrieval. So, these questions are answered by means of some objective parameters, namely precision, recall and F score. We now proceed to define them. We define them by means of sets, okay, but this can be adapted to the list situation, where the documents which come from the web are formed into a list. Okay. So, the slide would show very precise definition of precision, recall and F score. Look at these two circles. So, here is this actual set of things denoted by the symbol A, and what we have obtained is a set of things. We call it the set O, A and O. Now, it is conceivable that A and O, the actual set of things and the obtained set of things, intersect and produce this region. This is called the region of intersection between A and O. So, this is the region where the obtained documents or obtained entities and the actual entities agree. How is precision measured? Precision is measured as A intersection O, the size of A intersection O divided by the size of O. Okay. So, the agreement, the set of agreed upon entities, the actual entities and the obtained entities divided by size of the obtained entities. So, precision actually is measuring, if you look at the formula, it is actually measuring the proportion of entities which are obtained and are correct. Okay. It is measuring the proportion of correct entities out of the obtained ones. This is this ratio. Okay. This is clear. So, out of the ones which are obtained, how many are correct? This is the proportion. And if you multiply it by 100, then you will get the percentage precision. Recall, on the other hand, is the capability of the system to actually obtain things which are actually correct. So, this is expressed as the ratio of A intersection O, this area, size of this area, divided by the size of A, the actual entities. So, this is giving me a proportion of the entities from the actual set that are retrieved. Okay. So, do carefully note the definition of precision and recall. Both of them have the same numerator. Okay. Both of them have the same numerator, and if we divide the area of intersection divided by the size of what is obtained, then we get precision, which essentially refers to this point of amongst everything that is obtained, how many are correct. Recall, on the other, refers to amongst everything that is actually present, how much is retrieved. Okay. So, this is precision, this is recall. There is a measure which combines precision and recall, that is called F score. This is essentially the harmonic mean of precision and recall, 2 PR by P plus R. If the question is why is it harmonic mean and why not arithmetic mean or geometric mean, then just make this observation that harmonic mean is the least amongst all these means. Harmonic mean is less than geometric mean, less than arithmetic mean. So, if harmonic mean improves, automatically geometric mean and arithmetic mean also will improve. Now, the other thing one would note is that if A and O are same, okay, then precision, recall and F score all boil down to a single number. Okay. So, one you would possibly recall that in part of speech tagging we also used precision and recall. So, precision, recall and F score are general terms which can be used for the measurement of agreement between an actual set of entities and the obtained set of entities. So, we can of course, make use of this in our information retrieval situation also, where we find that the list of documents which are present. So, let us say we look at the list up to the 10th position. If we look at the list up to the 10th position, I will draw this on the paper. So, the documents which are obtained D1, D2 up to D10. So, we go up to the 10th position. Okay. Then we might ask what is the precision up to the 10th position, okay, which is written as P at 10. So, what is the precision up to the rank of 10? So, this can be easily answered. We simply find out of these 10 documents, how many are correct. So, suppose 5 are correct, 5 are relevant, then 5 by 10 or 0.5 is the precision at 10. Okay. So, that is quite easy to calculate. So, now we come to an important point. Precision for information retrieval is defined and practically calculatable. What can we say about the recall? Now, recall we said is the proportion of actual entities which are obtained. Okay. So, the a particular process has obtained a set of entities. How many of them are, what proportion of these form a component of what is actually existing. Now, here you can see the difficulty of the problem. It is difficult to answer this question easily. Why so? Because nobody knows what is the actual amount of information, on the web, how many documents are really relevant to a query. Nobody knows. Web is an ocean, okay, a very, very large repository of information. So, with respect to a query, if we want to find out what is the recall performance of the search engine, it is impossible to answer this question. So, suppose we concentrate only on the first 10 documents and out of them 5 have been found relevant. How this relevance judgment is done, we will see later. But these 5 forms what proportion of the actual documents present in the web, nobody knows. Okay. So, that is why the recall is not directly calculated for measuring the search engine performance. We will see what we do about this. Mainly what is calculated is precision at a particular rank, and these values are computed for different ranks and we take an average of these ranks. So, that is called mean average precision. We will discuss these issues in the next lecture.